Hey guys, this is the slideshow for A.3B. Please work these along with myself. Please work these along with me. And here we go. A.3B. This is nothing new. This is calculating the rate of change, the slope of a linear function using tables, graphs, or equation. So let's try that. Example 1. We have a table, and it says the cost of bus rides when purchased individually for a local bus system creates a linear function. The table shows some of the costs for particular numbers of rides purchased. What is the rate of change of the total cost with respect to the number of bus rides? So let's use our calculator. We're going to hit stat, enter, and you're going to see that we need to put in 5, enter, 10, enter, 15, 20, 25. I'm going to tab over, and now I'm going to hit 1250, 25, 3750, and 50. I'm going to hit 6250, and we got it in there. Okay, now I'm going to hit stat, tab 4, enter, and I know that it's going to cost me $2.50 per bus ride. So my slope, M, equals 250. If we did it this way with our table and we divided y divided by x, you would see that 1250 divided by 5 is 250. You would see that 25 divided by 10 is also 250. So forth and so on. Okay, so it's a constant rate of change. And if we were to write the equation, it would be y equals 250x. Okay, next. Let's go to the next one, and let's erase that. This person released a helium balloon into the air and recorded the height of the balloon in feet over time. The balloon's height can be represented by the linear function f of x equals 800x plus 6, where x represents the time in minutes since it was released. What is the rate of change in the balloon's height with respect to time? Well, they have it already done for you. Your slope is next to the x. So we know it's going to rise at a rate of 800 feet per minute. It also has a y-intercept, so that must tell us the man is releasing it from 6 feet. He's probably 6 feet tall. He releases it, and there it goes. So y equals mx plus b. Our slope is 800, and our y-intercept is 6. Okay, here's the next one. We have a table, and they want to know how much is she going to save each month. You can see from this table, she already starts with 235. So therefore, we have a y-intercept. I already know that by seeing that x is 0 and y is 235. So we know this is non-proportional. And let's put it in the calculator, and let's see what this is going to look like. So we have stat, enter, and I'm going to put in 0, 2, 5, and 12. I'm going to delete. I'm going to hit the delete button on that last one and go up, over, and I have 235. I have 339. I have 495. And I have 859. Delete that last point, and let's hit stat, tab 4, enter, and we know that she is going to save $52 per month and she starts with $235 in her account. So we know our slope equals 52. We know our y-intercept equals 235. And if we were to write this equation, we would write y equals 52x plus 235. Okay, let's go to the next one. Okay, this graph represents a linear function. Linear means line, so it's a straight line linear function. What is the rate of change in y with respect to x? Well, we need to find 2 points on the line, and they were nice enough to do that for us. Here's one exact point, and here's another exact point. And I can see that this is not proportional, and it's going through the y-axis at 4, so that's our y-intercept. So I'm going to count up. I'm going to go 1, 2, 3, 4. So my rise is 4. My run is 1, 2, 3, 4, 5, 6. My run is 6. So I know that can be reduced to 2 over 3. And I know if I was to divide that, it would equal 0.66. Okay? So we know our slope is 0.66. That keeps going. If I was to write this as an equation, I would write y equals 0.66 x plus 4. I want to double check my points, so I'm going to put them in a table. I'm going to double check my numbers, and I know that this point here is x is 6, y is 0. And I know this point here is x is 0 and y is 4. So I'm going to put my intercepts in calculator, and I'm going to hit second plus 712, clear that out, hit stat, hit stat, enter, and let's put in our points. We have 6, enter, we have 0, enter. I'm going to tab over, and we have 0, enter, and 4, enter. I'm going to hit stat, tab, 4, enter all the way down. And that's exactly what we put. So we checked our work, we're good. Let's go to the next one. Okay. They want to know, here's a graph, shows Marla's cost of driving her vehicle. What is the meaning of the rate of change of cost with respect to distance in the graph? So we can see that this starts at 0, 0, so we know it's going to be a constant rate. And if we go, oh, I just thought of something. I need to go back. How do I go back? This one. This rate is, when we did rise over run, 1, 2, 3, 4. Run 1, 2, 3, 4, 5, 6. Equals 2 over 3. Equals, what was it, 0.66? Yeah. And it is a negative because this line is going down. And we even did it on the calculator, and I don't believe I noted the difference, but when you do rise over run, be sure you look at the line. Okay? Sorry about that. Here we go. Let's go forward. There's that. Here's this. Wait, are we done with this one? No, we were doing this one. And then I was like, I forgot that. Here we go. Okay, so we know this is proportional, and we're going to rise 1, and we're going to run 1, 2, 3, 4, 5. So this is telling me it costs $1 for every 5 miles she goes. So that should equal 0.20. and it's going up. The line's going up, so it's positive. But let's put it in a table and double check. We have 0, 0. And we have x is 5 and y is 1. Let's put that in our calculator and double check. Stat, enter. I have a 0, enter, a 5, enter. Did that go in there? No. 5, enter. Then I have a 0, enter, 1, enter. Stat, tab, 4, enter all the way. And there's our, there we go. We know it's proportional. We don't have a y-intercept, and our slope is 0.2. Okay, we have another one here. I think we have 2 more, this one and one more. So we have a scuba diver that records his depth below the surface of water. At 10 seconds, he records a depth of 30 below sea level. So it would be minus 30. And at 40 seconds, he records a depth of 100 feet below sea level. What is the diver's rate of change of depth with respect to time? So we need to make a table for this because we have our x. Oh, sorry. Okay, there we go. We have our x and we have our y. And at 10 seconds, he records a depth of 30 feet below sea level. So let's put our 10 seconds here and our 30 here. And at 40 seconds, he has a depth of 100. So let's put that in the calculator and see what is our rate of change. What is our slope? Here's our calculator, stat, enter. We have 10, enter. We have 40, enter. I'm going to tab over and up, and we have 30, enter, and 100. Stat, tab, 4, enter. And we know okay, yeah, this is right. So we know each.
Teachers, pardon this interruption, but at dismissal time today, it is going to be a little bit different. When I call for bus riders, you will be going to the cafeteria today. Only for today, but to the cafeteria. So all bus riders will be going to the cafeteria. Thank you.
So we know at each second, he's going to be going down 2.33 feet. This is kind of a messy one. Where's the calculator? And they must start let's see. So the B is 6.66. Doing this the other way real quick just to see what it is. And yeah, so this did not come out very clean, but this is your slope, this is your y-intercept. Let's go to the next one. We should probably take that. I need to take that off the slides. Too much. Let's go to the next one, and let's hit that and this. And okay, this is similar. Miguel is on a biking trip with friends. On day 1, they ride 8 hours and travel 92 miles. On day 2, they ride 6 hours and travel 69 miles. On day 3, they ride 7 hours and travel 80.5 miles. What is the rate of change in miles with respect to hours spent riding? Okay, so we know that they go.
This time, all car riders go
Good
to
Lord.
the cafeteria. All car riders to the cafeteria.
I think I'm going to end it on this one because the bell is about to go. I think y'all have had enough of this. So anyway, you need to know how to figure slope from tables, graphs, and equations. That'll do it for A.3B. And for those that did want to finish this, we have our days here. And let's see, we have day 1, they ride for 8 hours and they travel 92 miles. On day 2, they have 7 hours, 80.5 miles, and I'm sorry, day 2 was 6 hours and 69 miles. So anyway, but we're not doing this. So that'll do it for A.3B. And thank you for watching.